This lesson is all about how to work with radicals, in other words, square roots. For now, we're going to be focusing on square roots. The same types of rules apply to cubed roots and fourth roots, etc. But again, for now, we're just focusing on square roots. If you have the handout printed from the website, you can follow along with the examples that I'm doing in the video. And there's some extra examples there that you can complete on your own once you've watched the video. Okay, so let's start with a quick reminder of how to work with radicals. So let's say we have square root of 16. Okay? That square root symbol is indeed called a radical sign. Okay? And a radical symbols would include the symbol for square root, cube root, fourth root, and any other root that you can think of. Okay? So if we want the square root of 16, what we want is to find a number which, when multiplied by itself, is equal to 16. So in this case, we know that number is equal to 4 because 4 times 4 equals 16. Okay? Taking the square root of a number is the opposite of squaring. So the opposite statement to this would be that 4 squared is equal to 16. Okay? Another example, square root of 121. Again, we want to look for a number when multiplied by itself will equal 121, or in other words, what number squared equals 121, right? And so we know that number is 11. Okay. Now, it's very easy to simplify a radical when the number under the radical sign is a perfect square number, in the case of square root anyway. So again, like the square root of 16 or the square root of 121, these ones are simple because 16 is a perfect square number and 121 is a perfect square number. Now we want to start to look at radicals that have numbers under the radical sign that are not perfect square numbers. So let's say the square root of 24, for example. Okay. Now 24 is not a perfect square number. There isn't a whole number which when squared equals 24. Right? And so what we want to do when we simplify radicals like this is we want to start by breaking it up into pieces, if you will. So 24, I can rewrite 24 as 4 times 6. Okay? Now, I know what the square root of 4 is. Right? Square root of 6, I could calculate that, but that doesn't come out to a nice number. The square root of 4 is equal to 2. I'm just going to leave this square root 6 here. Okay? Now, this is what's called a mixed radical, 2 times the square root of 6, or 2 root 6. Okay? Now, if you try on a calculator, you'll see that the decimal value for 2 root 6, or 2 times root 6, is in fact the same as the decimal value you get for the square root of 24. Okay? So through this process of simplifying radicals, okay, we're going to use some rules for multiplying or dividing radicals. So one rule that we applied here was for multiplication of radicals, we can actually say that if we take the square root of a number times another number, so a times b, that would be the same thing as taking the square root of a and multiplying by the square root of b. So that's a multiplication rule for radicals that we're going to use to simplify. Right? The division rule for radicals, similar. If we have the square root of a number divided by another number, then that would be equivalent to taking the square root of the first number and dividing by the square root of the second number. Okay? So you can try using some examples to prove to yourself why these two rules work. Okay, let's simplify another one. This time we're going to do the square root of 252. Okay, and we want to simplify this radical. So we want to see how can we possibly break up this number 252. Well, one way to break up 252, 252 is actually equal to 9 times 28. Okay? You might be able to find some other combinations of numbers that will work as well, but I found this combination that works. Okay? I know using the multiplication rule for radicals that I can split this up into the square root of 9 times the square root of 28. Okay? The square root of 9, that works out to be a nice number. That's 3. So we've got 3 root 28. Okay? Now we want to check and see, can this square root of 28 be simplified any farther? And indeed it can. So I can break up the square root of 28 into the square root of 4 times the square root of 7. Okay? And the reason I know this can be simplified further is because the square root of 4 works out to a nice number because 4 is a perfect square number. The square root of 4 is 2. Now I've got 3 times 2 times the square root of 7. Okay? I know that 7 can't be broken down any further. The square root of 7 can't be broken down any further because there is no perfect square number that will divide into 7. Okay? And then finally I simplify. 3 times 2 is 6, so I get 6 root 7 as my answer. Okay? So this one we actually did 2 simplifying steps. We broke up the 252 into 9 times 28 because 9 was a perfect square number. And we then simplified 28 further by breaking that up into 4 and 7. Okay? So this is the method that we generally use to simplify single radicals. And just keep in mind that anytime you're breaking up the number under the radical sign, you want to make sure that one of the pieces that you pick is actually a perfect square number, because otherwise you won't be able to simplify either of those two pieces that you've broken it up into. So again, in this case, we made sure that one of them was a perfect square number with the 9 here. All right, let's take a look at a division. So the square root of 8 over 25. Using the division rule that I mentioned before, we can break this into two pieces. So we have the square root of 8 over the square root of 25. Okay? And this is helpful because the square root of 25, well, that works out to a nice answer because 25 is a perfect square number. So we know the denominator is going to be equal to 5. Okay? Now the square root of 8, we can break that down. 8 has a perfect square divisor of 4. And so we can break that into the square root of 4 times the square root of 2. Square root of 4, we know it's 2. So we get 2 root 2 in the numerator over 5 in the denominator. So that's the simplified answer. Okay, here's an example where we're working with mixed radicals. So a mixed radical means that we have a whole number part and a radical part. Now, when we're working with mixed radicals, if we're multiplying, then whole numbers can be multiplied to whole numbers and radical parts can be multiplied by radical parts. So what I mean by that is here we can take 2 times 3 and we can take the square root of 5 times the square root of 20. Okay? Then we can multiply the radical pieces together and we can multiply the whole number pieces together to get a new mixed radical as our answer. So here, 2 times 3 we know is 6. Square root of 5 times the square root of 20. Now again, we know that if we have the square root of a number times the square root of another number, it's the same thing as the square root of those numbers multiplied together under the square root sign. So the square root of 5 times the square root of 20 would be the square root of 100, 5 times 20. Okay. And the square root of 100, 100 is a perfect square number, so we can take that square root, which is 10, and then we have 6 times 10, which is 60. So the multiplication of these two mixed radicals actually ends up being a whole number, 60. When we're adding or subtracting radical numbers, it kind of works the same way as adding or subtracting when we're collecting like terms in algebra. So let's say, for example, that we had 5x plus x minus 2x. Okay? Well, we know when we collect like terms, well, we've got 5x's plus 1x, which is 6x, and then minus 2 of the x's gives us 4x. Okay? Well, it works in a similar way with radicals. Here we've got 5 root 3's. We're going to add 1 root 3, which is 6 root 3's, and we're going to subtract 2 root 3's. So here we would get 4 root 3. In some cases, when you're simplifying expressions that contain radicals, it might be beneficial to break a fraction up into multiple fractions. So in this case, for example, we've got 6 plus square root of 63 over 3, but we know we can split this into two separate fractions as 6 over 3 plus the square root of 63 over 3. Right? So again, if we were to go backwards, if we added these two fractions, the denominator would stay the same as 3, and then we would add the numerators. So it's kind of like undoing the addition of two fractions. Now, if we split this up into two fractions, we can actually simplify this further. So 6 over 3, we know is 2, and the square root of 63, we can actually simplify that by breaking it down into the square root of 9 times the square root of 7, because 9 is a perfect square number that will go into 63 over 3. Square root of 9 is 3, so we get 3 root 7 over 3, which simplifies to 3 divided by 3 is 1, so it simplifies to just root 7. So when the radical is the same, when we're adding or subtracting these mixed radicals, then it's quite easy. It's just like collecting like terms. We just add or subtract the numbers in front of the radical sign, and we keep the radical sign the same. Things become a little bit trickier when we're adding or subtracting radicals that do not have the same number under the radical sign. So here's an example. The square root of 12 plus the square root of 50 minus the square root of 32 and plus the square root of 27. Now, if the numbers under the radical signs do not match up, we actually can't add or subtract the radicals as they are. What we can do, however, is see if any of the radicals will simplify first, because if we can simplify them, sometimes they might end up having the same radical number as one of the other numbers in our expression. So let's simplify the square root of 12. Okay. Now 12, we want to see, is there a perfect square number that will go into 12 evenly? And there is. The number is 4. So we can split that up into the square root of 4 times the square root of 3. Okay. Now we want to simplify the square root of 50. So again, is there a perfect square number that will divide evenly into 50? So yes, we can split that up into the square root of 25 times the square root of 2. Okay. Then we want to look at simplifying, and the square root of 32 can be broken up into the square root of 16 times the square root of 2, 16 being the perfect square number. And finally, we want to look at simplifying the square root of 27, and 27 we can break down into 9 times 3, so we've got the square root of 9 times the square root of 3. Okay. Then we simplify each of these pieces. So square root of 4 is 2, so we get 2 root 3. The square root of 25 is 5, and so we get 5 root 2. The square root of 16 is 4, and so we get 4 root 2. And the square root of 9 is 3, and so we get 3 root 3. Okay. Well, now we've got some like terms that we can collect. So we've got this term here that's got a root 3 in it, and this one's got a root 3, and so we can combine those. So 2 root 3 plus 3 root 3. I'm just going to write them together for now. And we've got similar radicals here, so we can write those ones together. 5 root 2 minus 4 root 2. Okay. And then because these two numbers have the same number under the radical sign, we can add them. So 2 plus 3, got 5 root 3's now. And then here we've got 5 root 2's, and we're taking away 4 of them. And so we're left with 1 root 2. Okay, here's a final example of working with operations with radicals. So we're going to have root 7 multiplied by 2 root 5 minus square root of 48. Now, we've used the distributive property before. So when we have things like 2x times x minus 5, we know that to expand and simplify, we're going to take 2x multiplied by x and 2x and multiply by negative 5. So we're going to do something similar here with the radicals. We want to take the root 7 and multiply by 2 root 5. And we're going to take the square root of 7 and multiply by negative the square root of 48. Okay. Now, square root of 7 and the square root of 5 here are both already simplified radicals. But what we might want to do is simplify the square root of 48 here first before we multiply through, because that would mean that we're working with smaller numbers instead of having to deal with whatever 7 times 48 is and then having to simplify that radical. So let's try and simplify this first so that we can work with the smaller numbers. Okay, so again, we're going to just write everything else out and we're going to focus on simplifying the square root of 48. So 48, there is a perfect square number that goes into 48. 4 will go into 48, but 16 will as well. So we're going to split this up into the square root of 16 times the square root of 3. Okay, 16 times 3 is equal to 48. And then square root of 16, we know it's 4, so we get 4 root 3. Okay? And now that we've got smaller numbers to work with, now I'm going to do the multiplication. So use distributive property, square root of 7 times 2 root 5. So we multiply the whole numbers first. So 1 times 2 is 2. And then we multiply the radical pieces. So the square root of 7 times the square root of 5 is the square root of 35. Okay. Then we take the square root of 7 and multiply by the second number in the brackets, negative 4 root 3. Okay. And so again, 1 in front of the root 7. So 1 times negative 4 is negative 4. And then the square root of 7 times the square root of 3 is the square root of 21. Okay. At this point, we look to see if we can simplify any further. Well, we can't subtract these two because they have different numbers under the radical sign. Can we simplify the square root of 35? So we look and see, is there a perfect square number that will divide evenly into 35? There isn't, so that one's simplified. And same with the square root of 21. There's no perfect square number that will divide evenly into 21, other than 1, of course. But splitting it up into the square root of 21 times the square root of 1 doesn't really allow us to simplify anything. Okay, so this is the answer.